Thanks. So great to see you all again. Thanks for the invite, Jill et al. Slide today, so I kind of wanted to take a slightly different tact and give a very sort of 30,000 foot discussion. Actually, I'm hoping this prompts discussion about what are some of the ways that you can use digital media of specimens once you have them. So some of the talks today have been about already. And I actually thought this talk might fit into what Jill had in mind for the second seminar or a second workshop. But actually, after listening to a bunch of the talks this morning, I decided this actually fits in quite well. So I'm really glad I decided to talk about this. This is going to come from the perspective of the sort of collection that I run, which is quite different from a lot of the collections that you all are involved with, which involve actual physical specimens. Our collection starts with media. It's media from the get-go. So it's not always digitized media, but it is media that even needs to be digitized. And even more nowadays, it's coming in digital format from the very start. So we don't need to worry so much about the finer points about how to digitize the specimens. It's already mostly digital, and the methods for digitizing audio have been around for decades. So it's pretty straightforward. And that's why I want to talk about some of the things that might be done with an app that they digitize. So our collection is the Macaulay Library. It's a large media library of behavior. So we have audio recordings of birds singing, we have videos of animals displaying, we have photos. And nowadays we actually have quite a few. We have over 2 million audio recordings. We have 58 million photos. And that sets up some opportunities, but also some challenges. And so what I'm hoping I can do is talk about some of the things we've been doing with this very sort of behavior, animal communication specific collection that we have, and have us discuss and think about how some of the things we're playing around with these days might be applicable to other kinds of collections that you all might be working with. Because in all cases, we start with specimens. There might be, study skins. There might be media like this tape. We digitize them, and so we develop some sort of digital media specimen or digital media representation of the specimen. And once it's in digital format like that, you can do all sorts of AI magic with it, right? So we can feed those images into algorithms that allow us to do different kinds of things. And what we're doing at the Macaulay Library is trying to think about different ways that we can use AI for curation of our collection, in particular data quality, for helping people do science with our collection, and then for engagement and education. And the kind of digitizing we're mostly doing, or the sort of machine learning we're mostly doing, is to develop models that can detect and classify birds in photos or in videos or in audio recordings. And so here we have, the algorithms have detected these two different species of bird. It's classified them, so it's identified what species they are. We can do the same thing with vocalizations. When we make a spectrogram from a vocalization, you can do the detection and classification models on those. And the way it's done is we have people who have an incredible amount of bird knowledge, like Taylor here, who really has an amazing ear. And she can go through and annotate these recordings and box every sound in every recording and say what species that is that's vocalizing. And likewise, we can do the same thing for photos. You can identify the photos, box the photos, feed those into the algorithm, and train the models, right? What you end up with. Oh, so those annotated recordings and annotated photos go to our machine learning crews at Grant Van Horn, who's at UMass Amherst, Sam Heinrich, who works with us at the Macaulay. They developed the machine learning model that gives us the output at the end for the detection and classification. And it looks like something like this. So here's a video. We're feeding this in, and it's testing the detection and classification algorithm, and doing the same thing down here with the audio. And so it's giving us detections of different species in both the video, so visually and acoustically in the audio. And so we've used the audio portion of that to develop what we call Merlin Sound ID, which is a sound identification algorithm for identifying birds from their vocalizations. Currently, it has about 1,200 species in the model from these different areas here, Latin, North America, and Europe, and then a little bit in some other areas, very little in places like Australia, a lot of Asia. But we're working on that. We have about 4,000 species that have annotations that are going to go into the model now. So what are we using it for? Okay, so I want to talk again about, so we have these machine learning models. Want to talk first about curation, and the way we're thinking about using this, or the way we're starting to use it now, is specifically for data quality. Because most of the data that we have coming into our collection are coming from citizen scientists. So it's coming from amateurs who do a recording or take a photo of a bird and they think they know what it is and they feed it in. And so we have huge issues with data quality, potential issues with data quality. And it's an issue because we have, last month in February, we had 33,000 audio recordings that were uploaded. We had over 1 million photos that were uploaded. So there's no way a human being can look at all that, right? We can't have a person listen to every recording or look at every photo and say, yes, that was a red blackbird, right? So that's where we're putting these detection and classification models into the upload pipeline. So when somebody uploads a photo and they have a bunch of photos of brown pelicans and they have one that's a white pelican, the algorithm detects that and says, are you sure that's a brown pelican? It sure looks like a white pelican. You might want to reconsider the species ID on that one. And so we have, we're building this pipeline that allows people to very quickly and easily change the ID on anything that they upload that gets flagged. But if they insist it's a brown pelican or whatever, then we actually flag it to have one of our experts look at it and verify. Now for research, I think there are two ways that we're playing with using machine learning to facilitate research. One is to help researchers find what they need. So, we have 60 million photos in our collection. How can anyone possibly find a photo that they need for a particular research project? So we've started using GPT sorts of approaches to use just everyday language. This is the tool that Grant's been playing with. It's not even a prototype. It's like a pre-prototype. It's almost like machine learning doodling that he's created this model that goes in. We're doing this with iNaturalist. So you can type in bird with yellow eye and it returns a whole bunch of photos of things that it thinks are birds with yellow eyes. So bird with long bill, bird with a nest. I mean, it's okay. Most birds with yellow eyes, it's mostly giving things that have yellow in the face rather than actually yellow eyes. But it's a first attempt. I think it's getting there. And that really helps someone do research projects that they want to do, like figuring out the breeding seasons for birds, right? So this amazes me. For about 2/3 of the species of bird on Earth, we don't even know when they breed. And so by saying, okay, I want to go through all of the photos and look for eggs, you can do that and you come back and there are eggs for a lot of species where we didn't know when they breed. And the other thing we're doing is actually working to develop tools that people can use for research and for conservation with the classification, the machine learning models that we developed. So one example, to conserve birds, you need to know where they are, right? To conserve snakes, you need to know where they are. And so at the Lab of Ornithology, we've developed from eBird data these really detailed, precise distribution and abundance maps of different species. For every week of the year, you can know where yellow warblers are and how abundant they are in the different pixels on this map, contrasted with a map you might see in a standard field guide, right? So this is great. These are an amazing data product coming from the eBird crew. And the reason it's amazing is because there's a lot of data pouring into eBird every day. So this is one day, 314,000 checklists were uploaded to eBird. Every white dot on here is a checklist. So there's a high data density, but it's not high everywhere, right? So most of Africa, not much data coming in. A lot of Asia, the Amazon. In a lot of these places, there's not data coming in. So this is where our media-based approach is what we'd like to further develop, because you can put automated recording units out in those areas where birders don't like to go. And you can have these automated recording units just record constantly. And you get reams and reams and reams of data, but then you're in the same trap where nobody can listen to that, right? So you need to use the detection and classification models. And likewise, a lot of birds are out at times of the day when birders aren't. So migratory songbirds mostly migrate at night. And so birders aren't out there at night watching them, but migratory songbirds give distinct species-specific calls while they're migrating. So you can record them flying over, figure out migration routes, when they're migrating, what kind of weather conditions facilitate that sort of thing. Put these recording units out, get a lot of data, then use the detection algorithms to actually turn those raw recordings into presence and abundance. Okay, and the last thing I want to talk about is what we've been doing to use these algorithms for audience engagement, to really get people engaged with birds, engaged with sending data to us, because it's a very important approach for us is something we call the data cycle. The more excited we get people about birds and birding, the more data comes into us that we can use for these sorts of approaches. And so we've really been trying to develop approaches to getting people excited about birds and conserving birds and giving us data. And so we put the Merlin Sound ID model that we've developed into our app. It's Merlin, which is an app people use to identify birds out in nature. It used to have Sound ID in it. It had other types of ID tools, but not Sound ID. And now you can take the phone and point it out at a bunch of singing birds and identify what's singing right outside the museums here. I did this morning. And when we added that capability to Merlin, this graph right here shows Merlin use per month. We're getting pretty close to about 1 million users per month in Merlin. And we added Sound ID. And so now, in the last summer, we had 3.5 million people using it per month. I'm sure we'll hit over 4 million this summer. So even, in the dead of winter, 2 million people are using it. Amazing. So now if you'll indulge me, it's late today, so I just wanted to, just for fun, I wanted to play this video of TikTok. It's a compilation of TikTok videos that Allie Smith, who works at the Macaulay with me, she went through. She said, "I wonder if people are talking about Merlin on TikTok." And she found about 5 hours of the material. And so she made a couple-minute compilation here that I just wanted to play. Okay. So now put that in just for fun, but also just to make a point, which is that almost nobody who saw that compilation videos was your stereotype murder, right? That we honestly feel like we're reaching different audiences and spreading the engagement that we do by having stumbled across this idea. And what I really would think would be a fun thing for us all to talk about is how we can do this with other digital media. They're coming from other collections, VR, proofs, whatever they are, and think creatively about using those for that kind of outreach because it's gold. And with that, thanks.
Thank you.